Hello everybody and welcome to today's lesson on multiplying and dividing rational expressions. Our objective, and I'm sure this comes as a big surprise now, is we will multiply and divide rational expressions. Rational expressions are somewhat like a fraction. Remember when we talked about number systems? Rational numbers are numbers that can be expressed as fractions, and rational expressions are also expressions that contain fractions. With fractions, one important thing is that we have to simplify them. They should always be in simplified form. When is a rational expression in simplified form? When the numerator and denominator share no common factors. So in order to get there, we have to factor both numerator and denominator if possible, and then simplify. And for rational expressions, we have to also check domain restrictions, but that is only if the expression has variables and only if it has only one variable. Okay, let's look at our first one, 15 over 65. Is that in most simplified form? Well, let's check. What number goes into both 15 and 65? The answer is 5. 15 is 3 times 5, and 65 is 13 times 5. So we can indeed simplify the 5, take care of the 5, and we end up with the fraction 3 over 13, 3/13, and that is the most simplified form of this fraction. Clearly, we have no domain restrictions here because there's no variable. Let's look at our next example though. X squared minus 81 over 2x minus 18. And here we also have to see if we can factor numerator or denominator. X squared minus 81. I know you saw that right away. This is a difference of perfect squares. So we have indeed x minus 9 times x plus 9. And in our denominator, we can also factor something out. We can factor out the 2, and we have x minus 9 left in parentheses. We can simplify the x minus 9, take that out, and our final simplified answer is x plus 9 over 2. We do have to check for domain restrictions though in this case, and remember from when we talked about compositions and inverses, we have to check domain restrictions before we simplify. And here's another example that clearly shows you why that's the case. If we look at our factored rational expression, we see we got x minus 9 in the denominator. That means that 9 is the number that is not allowed to be in our domain. When we look at our fully simplified form in green, that's no longer there, and we would not find a domain restriction if we looked at the fully simplified fraction. In our next example, let's factor our numerator. X is in both terms, so we get x times the quantity of x plus 7 over x squared. And we can now go ahead and simplify. X can be simplified against the squared, and we end up with x plus 7 over x. And again, we need to look for domain restrictions. Looking at our fraction in blue, we see that x is not allowed to be 0, and that is our only domain restriction, which actually in this case remains for a fully simplified form. But again, to be sure, we always have to start checking at the non-simplified rational expression. Moving on to the next example. Here we have a trinomial in the numerator, and let's see if that can be factored. is there a pair of numbers that multiplies to give us 6 and adds up to give us 5? And the answer is yes, those numbers are 2 and 3. So we have x plus 2 times x plus 3 in our numerator. And in our denominator, we can factor out x squared to have x plus 3 left in parentheses. So the x plus 3 cancels out for our final simplified fraction, x plus 2 over x squared. But I've said it before, and again, for our domain restriction, we need to check before we have simplified, because not only is x not allowed to be 0, as we could have seen from our green fraction, it's also not allowed to be negative 3, which we could only see from our rational expression before it got simplified. On to our next example. X squared minus 2x plus 1. Let's see if it can be factored. It can indeed be factored. Negative 1 times negative 1 is positive 1, but they add up to give us negative 2. This is actually a perfect square trinomial. It is x minus 1 squared. And in our denominator, we have yet again a difference of perfect squares. X minus 1 times x plus 1. X minus 1 cancels out one time, and we have x minus 1 over x plus 1 as our final result. And our domain restriction, x is not equal to 1 and negative 1. Our last expression on this page looks very different from the previous ones. Not only does it have rational exponents, it also has two variables, and we have an exponent on the outside that needs to be still distributed to the terms on the inside of the parentheses, and that's the first thing we're going to do. So let's distribute the 2. And remember, we need to distribute it to every term that's on the inside of our parentheses. Literally every term. That leaves us with 2 squared times a to the 4/3 times b to the 2/2, and I'm going to write it out for now, over a to the 2/6 times b to the 2/4. So remember, when we raise a power to another power, what we do is we multiply the exponents, and that's exactly what we did here. And now we can go ahead and do some simplifying. 2 squared is of course 4 a to the 4/3 times b to the first power 2 over 2. Then we got a to the 1/3 and b to the 1/2. Now, since we have like terms in both numerator and denominator, we can continue simplifying, and when we divide like terms, we have to subtract their exponents. 4 has no like term, but a to the 4/3 divided by a to the 1/3 means we subtract 1/3 from 4/3, get 3/3. In other words, 1, and b to the first power divided by b to the 1/2 power. 1 minus 1/2 is 1/2, and we have b to the 1/2 left. Now let's circle our final answer, just like the previous ones also. Here we do not have to look for domain restrictions because we have more than one variable. Okay, so now we can also talk about rational expressions more specifically. A rational expression has a polynomial as the numerator and the denominator. So how do we multiply rational expressions? Well, first of all, as we said before, we need to factor the terms if it's possible. Then we have to check for domain restrictions, and again, that is only if we see only one variable. We combine terms if needed and simplify as much as we can. Looking at our first example, let's start off by putting it all into one fraction and putting like terms next to each other. 12 times 2 times x squared times x times y. And in the denominator we got 5 times 3 times y squared times x squared. 3 goes into 12 4 times. We got an x squared, and luckily an x squared also in the denominator. And we got y times y, which is y squared, can be simplified against y squared in the denominator. And so our fully simplified rational expression is 8x divided by 5. We do not have to look for domain restrictions here because we started off with two variables, x and y. Okay, let's go to the next example. First we need to check if we can factor anything. Can we factor the trinomial x squared plus x minus 2? Yes, we can indeed. And we get x plus 2 times x minus 1. All on one nice large fraction times x cubed times y. That's our numerator. And in the denominator, nothing that we can do for the first term, but in the second denominator, x squared plus 5x plus 6, we had this before already once, and this can be factored into x plus 2 times x plus 3, and we have x times y squared. Now let's go ahead and see what we can simplify. X plus 2 and x plus 2 can be cancelled out. Here we get, for x's, we get x squared left in the numerator. And for the y's, we just got y, single y left in the denominator. So our fully simplified answer is x minus 1 times x squared over x plus 3 times y. This is our final answer. And yet again, we do not have to look for domain restrictions since we started off with two variables and also ended up actually with two variables, x and y. On to our last example on this page. And again, first thing we're going to do is try and see if we can factor anything. X squared minus 2x, we can factor out an x, and we are left with x minus 2. And for our trinomial in the second numerator, that can be factored into x plus 1 times x plus 3. Our denominator, x squared plus 2x plus 1, can be factored into x plus 1 times x plus 1. And from the x squared plus 3x, we can factor out an x. Then we got x plus 3. And this time I have put the x in the very back. Okay, and let's go ahead and simplify. X can be simplified against this x. X plus 1 can be crossed out, and so can x plus 3. So our final and fully simplified answer is x minus 2 over x plus 1. And this time we do have to check for domain restrictions. Let's look at our rational expression in purple. We see that the domain is x such that x is not equal to -1, -3, and 0. there are our 3 domain restrictions. And that's that. Good job. And now go ahead and watch the second part of this tutorial.